A lot of times it won't give you an error message that to help you out. Let's try that. Maybe it was just that it didn't like the fact that I still had the file open in Excel. It doesn't like to share. Let's see. Hours. Do I see it there? Excel. There it is. Don't include that. Now, maybe my copy is buggy. It could be my SPSS has a problem. It's buggy. I'll try updating it later on and getting it to work. We'll use the one that you'll have to take my word for it. Okay, that this does actually work. Yeah, I'm going to be going over. As a matter of fact, I am going to be going over a problem from homework 7 as well. Okay, the hypothesis testing. Okay, so trust me, this should work. It will work 99% of the time. That's the first time it hasn't worked for me in a long time. And it could be this is a newly installed version of it's not a new version of SPSS, but it's newly installed on this particular machine. It might need an update or something like that. It's not happy about something, but trust me, that should import the data into SPSS and save you the trouble of typing it in the way I did initially. Okay, that was just a demonstration. If you had an issue with that, don't worry about it. I just wanted to demonstrate that there's other ways to import data into SPSS than just typing it in. So we saw how to type data into SPSS or enter it manually into SPSS. We took a quick look at how to define the variable in the variable view. And now we're going to do our analysis. Okay, so let's see. Analyze, as always. We find most of our analysis when we're going to use the drop menus for doing our work instead of our syntax or programming language that's built into SPSS. For the most part, we'll be able to do almost everything we're interested in doing in this particular class from these drop menus. Okay, so I'm going to go to Descriptive Statistics. I'm going to go to Explore because that happens to be an option for descriptive statistics that gives me a lot more options than just this option, descriptives. Okay, I'm going to click Explore. I only have one variable. I'm going to move it into our dependence list. And there's a few options here. Down here, I can display only statistics. I can display graphs or plots, or I can display both. Over here in statistics, I can make sure that it's going to calculate my descriptive statistics by making sure that that box is checked off. And by the way, as part of Explore, it's going to calculate the confidence interval for me. And here's an opportunity for me to change this to something else. Since we're working with 95%, it's going to stay 95%. If I wanted a 99% confidence interval, I change that to 99%. These others I'm not worried about right now. Okay, plots. If I want to do some other plots in here, it's going to do a stem and leaf already. It does a box plot automatically in Explore. That's something you'll come across that it doesn't tell you here, but it will do one automatically. And I can tell it if I want, maybe let's do a histogram also. Okay, that'll give us an idea of how normally distributed this data is, if it is at all, for that matter. Okay, so those you have some other options about how to exclude cases, how to exclude variables. For instance, there's going to be situations where, in addition to the hours of TV, you might have also measured their BMI, or you might have, surveyed them on other things, and you may feel that, gee, if they didn't answer question number 3, I don't want to include them in this study because I only want to include the people that answered all the questions, not just some of the questions. So it gives you a chance to decide how to exclude cases. We're not going to exclude any now, so I'm not going to bother with that. Finally, I'm done. I can say OK. SPSS will open the output window. See, now we have 2 windows open. We have our input window back there, and we have our output window over here. Our histogram is here, and our histogram is clearly not normally distributed. But remember, central limit theorem is a pretty robust method, so we're going to go ahead with our analysis anyway. So let's see what it tells us. Our mean, rounded off to 3 decimal places, was 1.556, same as we got. Our standard error for our sample size of 9, based on a t-score of 2.306, I believe it was, our standard error came out to be 0.5556. This is rounded, just as we calculated before. We did it this time in an instance. And our confidence interval is 0.27 to 0.284. rounded off, right? Exactly the same numbers that we got before. Okay, pretty impressive. Yes, you can copy. You can copy and paste the numbers between Excel and SPSS. Let me see if I got Excel. If I still have this data on Excel. Up. I closed the file, didn't I? Open recent. Let's give it a try. See if that works for me. Copy. Minimize. I'm going to paste it in here. Bing. Right. We're able to copy and paste it there. So that part worked. I just have a bug in there. So pretty impressive, right? We got that information. I have my input window open over here. I'll go back to my output window. Remember now that when you quit SPSS, if you quit SPSS, if you want to keep your output window and everything that's in there and your input window, you have to save them separately. In other words, if right now I say save as, I save this input window. It's going to be saved as a file with a postscriptive .sav, okay? And then I quit SPSS. It doesn't save the output window. I lose that unless I also say save as and save the output window as well. That gets saved as a file that's a .spo. SPSS is relatively unforgiving on output files in terms of different versions. If you have relative to the relatively more recent versions, for instance, I think this is version 19. Let me see if I got that right. This is version 19. You pretty much can open and share these files between, say, version 20 or whatever the most current is, 21 or 20, back down to version 17 or 18 or something like that. But you get a little further back, and you can't always rely on saving these things. One of the other things that you might consider doing is on the output window, you can export the output window as an RTF file, like basically a Word document. So it's something that you might want to do if you're working at a computer in school and you want to save some of the charts or information that you have in there, and you don't have time, and you have many of them. Notice how if I keep repeating this, SPSS will just add on to these analyses over and over again. Oops. If I repeat this analysis, there it is again. If I repeat it again, right, there it is again, and you can see if I can scroll all through here, it just accumulates this. In fact, you can have so many analyses that you're testing that it's difficult to scroll up and down, so you can actually go over here to the sidebar and click to get to different parts of the analyses, get back to the top, and so on and so forth, or jump straight to the bottom. And this scrolls as well, so it's a little easier to find your way around when you need to, rather than use this window. Okay, so you can save it as an RTF file if you use the export command. Okay, or you can just copy and paste these into a Word document as you're working. So this seemed to work pretty well for us. Terrible looking box plot, right? Clearly ridiculously skewed, right? So this maybe is not the best example in terms of adhering to our assumptions, but again, pretty robust methods. So I think that we can work with this pretty well. Here you can see a little bit of a summary of what the data is for the original 9 people that we surveyed and so on. Okay, so, but we got a lot of agreement, and SPSS did this for us much more quickly, with much less chance of being wrong or inaccurate than if we had done it manually with a calculator or with, or even with Excel, which you don't have the problem of incorrectly calculating things, but you do have potentially the problem of maybe making some operator errors and stuff like that. Okay, so that's basically what we're looking for in terms of using, when we're working with small samples, when we don't know the population standard deviation, and we're forced to use the t-test, and we need to calculate a 95% confidence interval. Of course, if we want to calculate a 95% confidence interval of a proportion, remember 30% of the diabetics, 30%, 3 people out of 10 are diabetic, so we're estimating the population proportion of diabetes is 0.3 or 0.30. Well, we would do the same thing. That's our point estimate, 0.30. So if we want a 95% confidence interval based on that sample of 10 people, we would say that it was going to be 30%, 0.30, plus or minus t for 95% confidence interval, which is going to be around roughly 2.3, times the standard error for that proportion. In other words, the proportion that we would expect. The way the proportion is distributed, if we repeatedly sampled 10 people, sometimes we get 2 out of 10, sometimes 4 out of 10, so on and so forth. And the way we would get that standard error is that standard error is equal to P, our point estimate, right, which is 0.3, times 1 minus P, which is 0.7, divided by the sample size, which is 10. We'd calculate that and take the square root of the whole thing, and that would be our standard error. We'd multiply our t-score, 2.3, times our standard error, whatever that number came out to be, and we'd use that as our margin of error and add it and subtract it to our point estimate, which is 0.3. Okay, so it's basically the same process, except a different way of calculating the standard error, the standard deviation of the sample distribution, the standard error. Okay, so now let's move on to that next problem I was talking about. Okay, and we're going to look at a different homework now. Okay, so now I'm going to get this stuff out of the way temporarily. So let's see, and I'm going to open this other homework. Okay, and I'm going to take this last one here. Okay, when operating a machine, there's a little bit of a misdirection here down at the bottom. When operate, I think because I think I altered some of the wording in here and then left this one sample t-test thing, but we'll take a look at that. When operating a machine, the mistake is a good opportunity to examine how we would deal with something like this. When operating correctly, a machine for manufacturing diet supplements produces a pill that weighs 57.6 milligrams. Okay, that's what it's supposed to look like when it's operating correctly. A random sample of 8 pills had weights of the following: 1, 2, 3, 4, 5, 6, 7, 8. Sample size is 8. Okay, again, sample size is small. We don't know the actual standard deviation for all pills that maybe this machine makes 10,000 pills a day. We don't know what the actual standard deviation for that entire 10,000 pills. We can only calculate what's the standard deviation for our sample. Okay, and that's the way we're going to be working most of the time.